Welcome to this second tutorial on 8051 architecture. In this tutorial we are going to cover the pin diagram, the clock circuit, the reset circuit, and we'll also have some idea about the external memory. Now as you can see the pin diagram, the 8051 is available as 40 pin DIP. You may also find it in some other packages. For this tutorial we will be concentrating on the DIP package, and as you can see that pin number 20 and pin number 40, they are used for connecting the power, that is VCC and ground. VCC is 5 volts, ground is 0 volts, and that will power up the device. Apart from that you have 4 ports, port 0, port 1, port 2 and port 3. All the 4 ports are 8-bit ports and they use 32 pins of the microcontroller. Here you find that there are 2 pins, XTAL1 and XTAL2. These 2 pins are used to connect the crystal, and the crystal generates the internal clock frequency for 8051. And then we have a pin called reset, a pin called EA bar, ALE and PSEN bar. So that makes up the 40 pin package of 8051. Let us see some pins in more details. Here the clock circuit is shown. Pin number 18 and 19 are XTAL1 and XTAL2, across which the piezo crystal has to be connected. The clock circuit consists of a crystal oscillator, and generally a 12 MHz crystal is connected with the 8051 circuit. The crystal is to be connected between pin number 18 and 19, and as soon as we power up the circuit, you find that the crystal starts oscillations and the 8051 starts working. As a test, if you connect a CRO to the ALE pin, the signal can be seen. It will show some waveforms indicating that the crystal oscillator has started working and the ALE signal is out. We also find 2 capacitors connected across the crystal to ground. A 30PF is connected in both the circuits, that is from XTAL1 to ground and XTAL2 to ground, and these are noise reduction capacitors which are helpful to stabilize the crystal oscillator. So a 12 MHz crystal is generally connected with the crystal circuit of 8051. Now here we come across another important circuit of 8051. These circuits are important because apart from any other type of peripheral interfacing, it is necessary to connect these circuits with the controller. Whatever you connect in the interface circuits, but these circuits have to be connected, and therefore it is necessary to study them. The reset circuit for any microprocessor or microcontroller device has to generate a power on delay. Whenever you switch on the power for any microprocessor or microcontroller, then the switching on of the power will generate a large number of transients in the circuit, and before the transients settle, if the controller or the processor starts working, then you may find that it may give some errors in the circuit, and therefore it is very much necessary that after power on, the processor or the controller should remain in the reset state. After a few milliseconds, it should come out of the reset state. Now the reset input of 8051 is active high. Means that when it is 1, or the controller goes in the reset state, and when it is 0, the controller starts working. So if you want the controller to work, you have to bring down the reset value to 0. Now here in this circuit, you find that the reset pin is connected to an RC circuit. The capacitor charges through the supply and a voltage drop is developed across the R, that is the resistance connected in the circuit. Generally it is an 8.2 kilo ohm resistance and a 10 microfarad capacitor. So when the capacitor charges, it generates a 1 at the output. This 1 will hold the processor in reset state. After some time, when the capacitor has acquired adequate charge, the voltage across the resistance will start falling. The voltage across the resistance is governed by the current or the charging current of the capacitor. And as the capacitor starts charging, the charging current will reduce, and therefore controller will come out of the reset state after some time period. The time period is decided by the RC constant of the circuit, and here the design which is shown over here is a delay which is adequate to allow all the transients to settle in the power on state. Apart from that, there is an optional switch shown in our circuit through dotted lines. You may or may not connect this switch. If you want to manually reset your controller, this switch is required. When you press this switch, the capacitor will discharge through the switch. As soon as you release it, the capacitor will start charging and produce a 1 at the reset input, and this 1 or this high level will reset the controller. It will take the controller in the reset state and it will generate the reset process. So this is how the power on delay circuit works in 8051. Now next we want to talk about the internal and external memory of 8051. The microcontroller has got a 4 kilobyte of internal memory. That is what we learned in the last tutorial. Here I have shown various versions of 8051 and the memory, internal memory, which is offered by these versions. You have got 8051, then there is 89C51, which is a popular microcontroller from Atmel. Then you have S89S51, that is also from Atmel. Controllers are manufactured by various other companies based on this architecture. I have not covered all the controllers from various different companies, but here I have given the details of 8051 and the processors or the controllers manufactured by Atmel. 89C51 is a controller which has got 4 kilobytes of internal memory, and it has a programmer parallelly programs the 89C51. Contrary to that, 89S51 is a controller which also has 4 kilobytes of memory, but it requires serial programming. Similarly, we have 89C52 and 89S52, which has got 8 kilobytes of internal memory. Some higher versions will have higher amount of internal memory. Sometimes it is required or it is felt that the internal memory is less, 4 kilobytes or 8 kilobytes is less, and you want to use more memory with the processor, then in that case you will have to connect the external memory. This external memory can go up to 64 kilobytes. If you want that your controller should fetch the instructions from the external memory and execute them, then the EA pin of the microcontroller should be made low. As a result, EA bar is active and therefore external enable is active and the external access is possible. If EA bar is connected to VCC, then the external memory is not used and only the internal memory is used. So that is how you can use the external memory of 8051. Use of external memory is also linked with the port pins of 8051. We'll discuss that in more details at a later. So that brings us to the end of the second tutorial on 8051 architecture. Thank you.